if we type grep-n Alabama in the states file, we will get the line number that the pattern Alabama is sitting on. But when we type grep-b Alabama in the states file, we get 0 for the byte offset of the line the pattern is on. Think of the B in the -B option as standing for byte offset. You may be asking, what the heck is a byte offset? And that's an excellent question. Let's go over what the byte offset is, and then we'll talk about why the byte offset is a thing. If we open the states file, here is what we see versus what the computer sees. Notice how on the left, we see nice, clean text, but on the right side, what the computer sees is this same text with additional characters. The \n character on the right tells the computer, this is the end of the current line, please go to a new line. Each of these new line characters are worth 1 byte. The 0x20 characters on the right are the hexadecimal representation of a space, and each instance of the 0x20 character or characters is worth 1 byte as well. This example sets us up to understand what a byte offset is. Please note that the special symbols in this example are colored blue-green to highlight their existence, not to imply that the computer sees them in a different color. Many of you know that computers think of everything in bytes. The letter A, that's 1 byte. The number 7, it's a byte. The new line symbol, 1 byte. The smiley face emoji we're also used to, it's a series of bytes. In our trusty states file, all letters, numbers, and symbols have a byte position based on where they appear inside the file. In this slide, the black letters represent what the computer sees in our states file, and the red numbers tell us the byte position of each character or characters immediately below it. We see here that the word the begins at byte offset or byte position 8 with the letter T in uppercase. So if we go to our bash window, we'll clear our screen, and we type grep-b the in the states file, it gives us 8 because the word the begins at byte offset, aka byte position 8. Let me show you another little trick. If we go back to our slide, here we see that the word state starts at byte offset or byte position 12 with the letter S. So if we go back to our bash window again and we type grep-bo state in the states file, and remember the O stands for only and tells grep to only return the pattern specified and not the whole line the pattern sits on. So if we type this out and we hit enter, you can see here that it gives us byte offset 12, which is where the word state begins in the byte position, as you can see right here. Now, why is byte offset or byte position a thing? Well, computers do not think in lines or characters. Instead, they only see a continuous stream of bytes in memory or storage. Where we see lines, characters, pictures, etc., the computer only sees a continuous stream of bytes. So we need a method of telling the computer a precise machine-level position inside that byte stream. If we think of a file as a movie reel, then a byte offset is like a frame number. It tells you exactly where in the reel something happens. This way, if someone says, the explosion begins at frame 1623, we can jump straight to that frame. There's no guessing involved. Said in another way, a byte offset is a position in a file, counted in bytes from the start. Computers read files as raw bytes, so offsets let tools jump to, extract, or change data precisely. People in computer forensics, reverse engineering, and low-level programmers require this level of precision. So just think, you're now scratching the surface of computer forensics just by watching this video. If you guys want to learn a specific new Linux command, or you're frustrated with your understanding of a command currently, let me know in the comments and maybe I can make a video explaining it. And if you know of someone else that could benefit from this video, please share it with them. Other than that, thanks for hanging out with me. Have a good one.